Hi, and welcome to Gaming with EaselJS, an advanced Canvas course on Tuts+. In this and the next lesson, we're going to put together a complete, functioning, tile-based puzzle game. In this lesson, we'll aim to get the basic classes, the game environment, and our first level set up. Then in the next lesson, we'll work out the game logic. The game we are going to be making is called Sokoban. As you can see, it is a simple tile-based puzzle game where a character has to move boxes over certain points on the map. Its simple logic and levels make it a great candidate for learning game design. So let's get started. We'll open up our Tuts Canvas project, start it with Grunt, and we can navigate to localhost 9001 to see the result of our last lesson. Let's start off by giving ourselves some level data to work with. We'll call this file levels.js, and we're going to be exporting an array of levels. Each array item will be made up of an object, which will have a name, in this case level 1, and the actual map data. The map data is made up of an array of arrays. Each of these arrays represents a row on the map. So as I complete the array, you can see that we have a map made up of single digits. 1s represent solid blocks. 2s will be diamonds. 3s will be boxes that we have to use to cover the diamonds. And 4 will be our hero. Let's remove some of the clutter. We won't need to listen to the tick because we can essentially update the canvas only after every user interaction. We won't need this here. What we essentially need to do is iterate over our two-dimensional array to build our level. We'll get our map from level0.map, and then we can iterate over it with the for-each method of the array. So the first for-each will be iterating over our rows, and the second for-each will be iterating over each individual tile. We'll decide what we do with each of these tile numbers in a second. Now we can go and create our basic tiles. Let's start off by creating a base tile class, and then our hero class and our diamond and block and box classes can all inherit from that. We'll create a new file, but this time we're going to inherit from shape. We'll call our class tile, and we'll expect an X and Y argument to be passed in. So we're inheriting from shape, and we'll need to call the shape constructor. An important thing to remember is that the shape class actually accepts an argument of a graphics object. Now we specifically don't want to set a graphics object, so we'll pass null and use call instead of apply. Now the first thing we want to do with any tile on initialization is set its position. So we're going to create a setPos method and call that on initialization. And setPos can look something like this. Now when we're putting down tiles in the display, you have to remember that we'll have to position them correctly based on a number of pixels. But our map is not based on pixels, it's based on tile number. What would be nice is if we can just pass in the tile number to any of our tile objects, and they will correctly position themselves in terms of pixels themselves. We can do this by having a tile size constant defined, and when we set pos of x and y in the game coordinates, it will convert that to pixel coordinates. We can also keep properties specifically so we can find out our game x and y coordinates. So we can save this as tile.js, and now our hero becomes a lot simpler. It simply needs to require the tile class, subclass it, call the constructor, and then it can do its own specific functionality such as setting its name to hero and setting up its graphics object. Back in our main file, we can include our levels object. Just change the name here to levels with a plural, and change this reference here to utils, not util. Okay, so we have our hero. Let's go on and also create a block class. We'll just change the name to block, change that to block, and the blocks can be black squares, normal rectangles. We'll set up a box class, make the boxes red, and a diamond class. Remember, we have to push the boxes over the diamonds. Sorry, I accidentally made a black class, it should be block. And for diamond, we will make a blue circle. Okay, now that we have our classes all set up, we can import them like so. Hero, diamond, box, and block. You can see them being imported here. And now we're going to create a map of classes, which we'll use to associate each number in the map array with a particular class. So 1 is block, 2 is diamond, 3 is box, and 4 is our hero. So for each tile of our map array, we're going to first get our tile class. By searching by passing in the tile number to our class map. Then, if such a tile class exists, we're going to do the following. We'll create a new tile instance using new tile class and passing in the index x and index y. This is basically the x and y position of this particular tile. We'll then add that tile to the stage, although later on we'll probably set up a separate group to hold the map objects. And we'll replace this element of the array with the tile instance. So instead of having a map of numbers, we'll have a map of actual block instances. Now what's probably better is to set that up as a new array. We'll call it tiles. For each row, we'll push a new array into the tiles map, and then we'll add our instance to that array. At the end of it all, we can console log tiles to see what it looks like. Not bad. We've got our array of objects. I should also include the empty objects as well. So I'll put this line outside of the if statement, and we're either putting in the instance or a null object. There we go, block, 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 null, null, null. That's the first line up here. Block, 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 and the rest are null. Notice that the circles are a bit off center. This is because they're positioned differently, and we'll have to set their registration points specifically to -25 for x and y. There you go. We have our hero here, our map, our boxes, and our diamonds. Let's tidy this up a bit. We'll start by making stage a module level variable and also a variable for our map group. And we'll move all this logic here into a prepare world function. We'll set up our stage, set up our group. So now we can move our map group around and all of the tiles will move in relation to their parent group. Before we go, let's just test one thing. We'll expose our tiles array on the window. To get an idea of how it will be working with these objects, we can look for our test array, find the hero, which is in the 4th row in the 7th cell. Remember, we're using with 0 notation. Remember, our array is indexed to 0. Now once we have our hero, we can call set pos and pass in an x and y. Let's try 2, 2. Now remember, we're not currently updating our stage, so let's expose the stage as well. Set the position, and then we'll call stage update, and you can see our hero's position has changed. So we now have a very clean way of positioning our objects within the tile map without having to think about the logic of their positioning in terms of actual pixels. We can think of the map as positions 1 and 2, or 3, 4, or 5, 6, and they'll just position themselves correctly because they all inherit from the tile class. That's all for this lesson. We've got our map already set up, and in the next lesson we can start working on the actual game logic. Ciao!